Stop.
Functional distinctions between the descending and ascending limbs of the loops of Henle of juxtamedullary nephrons are critical to the establishment of the vertical osmotic gradient in the renal medulla. The descending limb is highly permeable to water and is the only segment of the tubule that does not actively extrude sodium chloride. The ascending limb actively transports sodium chloride out of the tubule and into the interstitial fluid. It is always impermeable to water, so salt leaves without water osmotically following along. Even though the flow of fluid is continuous through the loop of Henle, we will visualize what happens step by step. Before the gradient is established, the tubular fluid and medullary interstitial fluid are isotonic at 300 milliosmoles per liter. The active salt pump in the ascending limb transports sodium chloride out of the lumen until the surrounding interstitial fluid is 200 milliosmoles per liter more concentrated than the tubular fluid in this limb. Water moves passively out of the descending limb until the osmolarities of the fluid in the descending limb and the interstitial fluid become equal. We now advance the entire column of fluid in the loop of Henle. The ascending pump again transports sodium chloride out while water passively leaves the descending limb until a 200 milliosmol per liter difference is re-established between the ascending limb and both the interstitial fluid and the ascending limb at each horizontal level. As the tubular fluid advances still further, the gradient is disrupted once again at all levels. Again, active extrusion of sodium chloride from the ascending limb coupled with the net diffusion of water out of the descending limb, reestablishes the 200 milliosmoles per liter gradient at all levels. As this process continues, the fluid in the descending limb becomes increasingly more hypertonic until it reaches a maximum concentration of 1,200 milliosmoles per liter at the bottom of the loop. Because the interstitial fluid always achieves equilibrium with the descending limb, a gradient is likewise established in the medullary interstitial fluid. In contrast, the concentration of the tubular fluid in the ascending limb progressively decreases as salt is pumped out and water is unable to follow. Note that even though the ascending limb pump can generate a gradient of only 200 milliosmoles per liter at each horizontal level, this effect is multiplied into a large vertical gradient because of the countercurrent flow within the loop. This concentrating mechanism is known as countercurrent multiplication.